Welcome to your favorite pre-calculus class. Good to be back. Today we're going to take a look at right triangle trigonometry. So we've looked at it from the unit circle approach, and now we're going to look at it from the second perspective, which is right triangle trigonometry, which you've been exposed to a little bit in geometry. Okay, so first of all, let's go ahead and consider a right triangle here. Let's draw it with our theta angle right here. And if we're looking at this, of course, the side opposite, we're going to go ahead and we're going to call that the opposite side, right? The side that's right next to it, we're going to go ahead and call that the adjacent side. That's, okay, right next to, okay, but it's not the hypotenuse because we know the hypotenuse is the side that's opposite that 90-degree angle, that right angle right there, okay? And from that, we have your right triangle definitions of trig functions. Okay, right triangle definition of these 6 trig functions. Okay, and there's a few ways that you can remember this, but theta in this sense, theta has to be an acute angle of a right triangle. So let's let theta be an acute angle of a right triangle. Okay, that's our restriction here for this, for these definitions. Okay, acute angle, so less than 90 degrees. So we have sine, we have our cosine, and we got our tangent, right? Now, a lot of people like to remember SOHCAHTOA, S-O-H-C-A-H, SOHCAHTOA. Okay, you see the S-O-H-C-O-A, SOHCAHTOA. Okay, where your O stands for your opposite side, H for hypotenuse, A for the adjacent side, H for your hypotenuse, and so on. Okay. Okay, so there's your SOHCAHTOA if you want to remember that. Sine equals opposite over hypotenuse, cosine is your adjacent over hypotenuse, tangent is your opposite side over your adjacent side. I like to remember, this is my personal preference, oh heck, another hour of algebra. That's how I like to remember it. But you can do it however you like. Again, that's oh heck, another hour of algebra as I undo those. Okay, so however you remember that, that's a great way to remember your, blow this up again, sine, cosine, tangent. Okay, well, we know the cosecant's the reciprocal of the sine, don't we? The cosecant. And one way you can remember that is S goes with C, S goes with C, where cosine goes with S, secant. Okay, S goes with C, C goes with S. Of course, tangent goes with cotangent. That's just kind of makes sense with the name there. Oh my gosh, that's terrible. Okay, and of course so if the cosecant's 1 over the sine, that's going to flip those over, isn't it? And if the secant's 1 over the cosine, it's going to flip those over if you were to simplify that. And finally, the cotangent, since the tangent's opposite over adjacent, the cotangent's going to be adjacent over opposite. Okay, so there's our right triangle definitions here. Okay, so let's see if we were to go out for a minute. Let me get a new sheet here. Let's go ahead and practice a little right triangle trigonometry here. Let's use the triangle to find the exact values of the 6 trig functions. So use the triangle to find the exact values of the 6 trig functions. Let's let our theta be, you know, at this time, let's let our theta be right here, okay, on this right triangle. And let's let this side be 2, and let's go ahead and let the hypotenuse be 4. So the 2 side, you see how the the theta's up there, so that is going to be your side opposite, isn't it? And this time your side adjacent is going to be right there. Now we don't know what the adjacent side is. We need to find that, don't we? So, but we know the old Pythagorean theorem says, hey, a squared plus b squared equals c squared, doesn't it? A squared plus b squared equals c squared. So we go ahead and solve for that adjacent side because we're going to need that when we do all six trig functions. Evaluate all the six trig functions. Sorry for this angle. Okay, 2 squared plus your b squared equals 4 squared. So your b ends up being 12. B squared ends up being 12. B equals 2 root 3. Well, plus minus 2 root 3, but we know it's got to be 2 root 3 because it's a length, so it's got to be the positive 2 root 3, whatever that is. Okay, so this is, erase this, and we know that is 2 root 3. Okay, and then we say, okay, let's find all these, sine, cosine, tangent, and we say, oh, heck, another hour of algebra. Love it. But really you're thinking, I love algebra. Here we go, sine theta, opposite side would be, so we got the 2 over the hypotenuse 4. 2/4 or a half. So the sine of theta is a half. Cosine of theta is going to be the adjacent side over the hypotenuse. So 2 root 3 over 4. Of course, that's going to cancel, give us root 3 over 2. And finally, the tangent is going to be the opposite side over the adjacent side. So 2 over 2 root 3. Those are going to cancel, leave you with 1 up there. So you got 1 over root 3. Of course, we got to rationalize that. So the tangent is really root 3 over 3. Okay? And then the other 6, pretty easy. So you take, well, s goes with c, cosecant. So I got, instead of 1/2, I flipped it around, 2 over 1, right? Or just 2. So the cosecant's 2. C goes with s, cosine goes with secant, right? So that is really 2 over root 3, right? 2 over root 3. Of course, rationalize that. 2 root 3 over 3. Okay? 2 root 3. There we go. Okay. Cotangent. Again, we're flipping that over. And you know, if you want, you could take it from right here, and it'd actually make things easier. You know how you had 2 over 2 root 3 originally? So it's 2 root 3 over 2. See how those cancel? Instead of taking that one, 3 over root 3, and actually having to rationalize it. So just say, oh, saves me a step right there, because it's involving radicals here. Okay, so that's how you go ahead and you find the exact values for the 6 trig functions. Now, if you guys remember, from geometry as well, you have these special right triangles. Okay, you had your, let's go ahead. You had your 45 degree, 45 degree, 90. You had your 45, 45, 90, and the side lengths here are 1, 1, root 2, or sometimes people will write x, x, x root 3. And then your other one was your 30, 60, 90 right triangle. So 30, 60, 90. And how I like to remember this is the side opposite, that smallest angle is 1. And I just say hypotenuse 2, remaining side would have to be root 3. Okay, so side opposite 30 is the one, hypotenuse 2, and the other one root 3. And then that other one, of course, is 1, 1, root 2 on the 45, 45, 90. 1, 1, root, oh my gosh. Just kidding about that. 1, 1, root 2. Okay. So there's your special right triangles, if you guys can remember those. You got your 45, 45, 90. You got your 30, 60, 90. Highly recommended to memorize that. Okay. So if you're finding, you know, you could go ahead and do your Let's go ahead and find the trig functions. We'll do a few of the trig functions for, how about for the 30, 60, 90 special right triangle. Let's do it for that one. So let's say, let's find the sine at 30 degrees. Well, that'd be opposite over hypotenuse. The hypotenuse is 2, right? Cosine of 30 degrees, adjacent now, which would be the root 3 side, adjacent, I write that, don't I? The adjacent side over the hypotenuse, right? The tangent 30 degrees would be, oh heck, another hour of opposite algebra adjacent, 1 over root 3, 1 over root 3, just root 3 over 3 once you rationalize that, right? And then, of course, S goes with C, cosecant 30, 2 over 1, and so on. Secant 2 over root 3, 2 root 3 over 3, anyways, and so on. Cotangent 30 degrees, 3 root 3 over 3, okay, or root 3 over 1, okay? So that's how you'd find that using that 30, 60, 90. What if you were doing it for, instead, the sine, let's go 60 degrees now. Well, the opposite side here is root 3. Opposite over hypotenuse, right? Cosine 60, I'm sorry, I'm doing a 60 degree here. Adjacent over hypotenuse, 1 over 2. And finally, tangent opposite over adjacent, so root 3. Of course, you could flip those if you want to do the cosecant, secant, and cotangent. Okay, so that's how you would approach those. You could do the same thing with that 45, 45, 90. Okay, let's move into some co-functions of complementary angles. Co-functions of complementary angles. Let me get out of this for a minute. Do a new one here. All right, co-functions of complementary angles. So sine of 90 degrees minus theta is actually the same thing as the cosine of theta. Okay, the cosine of 90 minus theta, guess what that is? That's the same thing as the sine of theta. Okay, the tangent of 90 minus theta is the cotangent of theta. Okay, and then this works also cosecant. So cosecant of 90 minus theta is actually the secant. The secant of 90 minus theta is, guess what? The cosecant. And the cotangent of 90 minus theta is the tangent. Okay, so the tangent there. So for example, let's say you got, I don't know, sine, let's let theta be 45 degrees, right? So the sine of 90 minus theta is the sine, or it's the cosine, good grief, cosine of theta, right? So if theta is 45 degrees, guess what? In this case, the sine of 45 degrees is the exact same thing as the cosine of 45 degrees. So you just got to say, oh, well, 45 degrees, I could figure that out. So that's 45, 45, 90, 1, 1, root 2. And then you say the sine of 45 is the same thing as the cosine of 45. In fact, let's do them both. Sine opposite over hypotenuse, 1 over root 2, right? Cosine adjacent over hypotenuse, 1 over root 2. You see how those are the exact same thing? Root 2 over 2, root 2 over 2, and I just got to finish this video. Thank you. We'll move on to the next one.